In exercise 12.5, you're asked to find derivatives by rule. Now, for a number of historical reasons, we can use two notations to do this. These are both on your formula sheet. I always like to think about this as when I take derivative, I'm taking some of the power out of the function. So when we do this, the power reduces by 1. The other notation, exactly the same, except I use f prime x, n k lots of x to the n minus 1. Now, both notations are quite okay to use, so please bear in mind when you see a question, we tend to use the notation at hand. And on that, the very first one we look at, we've got a notation that's a little bit different. We still do the same thing. I do it in bits. That becomes 8 times 5, which is 40, x to the power of 7. And that's 12 times a half, which is 6. The power reduces by 1, x to the 11. So my final answer, 40 times x to the power of 7 plus 6 lots of x to the power of 11. In B, I'm asked to differentiate that phrase with respect to t. So I've got 2t cubed plus 4t squared minus 7t plus 12. So dy, I've called dy, over dt, dx, multiplying through by the power. Now, if there's no power, that's t to the 0, it becomes 0. So that's 6t squared. 2 times 4, 8. The power reduces by 1. Minus 7. Answer. Power reduces by 1. If there's a number by itself, it becomes 0 because t to the power of 0 is 1. You're multiplying through by 0 in that instance. Continuing on the same theme, when I was a student, I used to actually put little arrows through to remind myself to work the power down by 1. That will simply become 16x plus 6. Before I start 1D, I've got to simplify it. I can only work a derivative when I've got a function with just single units of individual indices. So when I do that, 2 goes into 4 twice, and that will be x to the power of 1. Take a half lots of x to the power of 3. Only then can I find the derivative or differentiate. It becomes 2 minus 3 over 2 x squared is my answer. So always when you've got a situation like this, work your indices first. So you've got an index to a power. Now, it might be fractional, it may be negative. If it's negative, you can work it through at the end. But just make sure that you've got a term at a time with an index with a rational function to work with. Rational number to work with, I should say.